Hello everyone, this is Doug, and in this video we're going to talk about how to balance chemical equations. I'm going to give you a few tips, show you some examples, and hopefully by the end of this video you'll be able to do a whole bunch of worksheets and practice on your own. So chemical equations, right, just tell us what reacted and what was made from that reaction, right? And we talked before about how a chemical reaction is simply when you take your atoms and you rearrange them, right? We don't create atoms, we don't destroy atoms, we don't transform one element into another one. You just take those building blocks and you rearrange them to make new stuff, right? And you may remember from previous videos that we call the stuff on the left-hand side the reactants or starting materials. So reactants. And then the other side here, right, are the products. So here's an equation, right, that says that if you take 1 mole of sodium and you react it with 1 mole of chlorine, right, so 1 mole of sodium, you react with 1 mole of chlorine, that you get 1 mole of sodium chloride. And to help us kind of visualize this out, right, I have my sodium drawn out here, just one sodium atom representing like 1 mole. I mean, you could say moles or atoms, it doesn't matter. And then you have a chlorine, so here's a chlorine molecule, just one. And then here's a formula unit of sodium chloride, right, the ionic compound sodium chloride. And when we're looking at this, right, what's important to remember always is that this reaction arrow is kind of like a before and after, right? So we have the state of things before the reaction and the state of things after the reaction. And what you've probably already noticed, and it's the title of this video here, right, is that this does not look balanced, right? Because if I look over here on the reactant side of things, I have 1 sodium atom, but I have 2 chlorine atoms, right? I've got 1, 2. Now that's not problematic in and of itself, but if you look on the right-hand side, I have 1 sodium atom and I have only 1 chlorine atom. 1 Cl, right? I only have 1 Cl. The sodiums are not problematic. You start with 1, you end with 1. That makes sense. But you can't start with 2 chlorine atoms and then just wave your hands and with a magic wand and all of a sudden it disappears. It has to be somewhere because, again, reactions are just where you rearrange stuff. You have this conservation of mass, conservation of matter. It doesn't disappear on us or anything, nor would things just appear. Like I couldn't have 5 chlorine atoms on the right-hand side all of a sudden show up out of nowhere, right? My analogy before was that this is where you take your your dinosaur Lego set and you break it down with those pieces and then you build a giant octopus from the same thing, right? It's the same building blocks. You have to have the same stuff. Nothing goes away. It's all in the same place. So we would say this reaction right here is not balanced. Not a balanced equation. So what do we need to do? We need to balance it. And the way we're going to balance it is by adding coefficients in front of these chemical species. So let's take a look at that. So what I'm going to do, right, so to balance chemical equations, what I'm going to do here, right, is I'll write this. I just mentioned this in the previous slide, but you need to add coefficients. Right? And coefficients, if you remember, are are numbers in front of those chemical species, whether they're atoms or compounds or whatever they are. And the other big important thing is that you do not change the formulas at all. Do not change the formulas. Right? It might be convenient to be like, oh, well, you know what, I can fix this. I'll just erase that 2 for the chlorine and then boom, 1 sodium, 1 chlorine on either side. Nailed it, done. But that just doesn't represent reality, right? Chlorine is a diatomic element. It comes in pairs. It's 1 chlorine bonded to another chlorine. You can't just pretend that it's not so. Ditto, I cannot just say, okay, well, I'll just change this to NaCl2. And then now I have 2 chlorines on both sides. I cannot change sodium chloride, right? Because the whole reason why it's a 1-to-1 ratio, where there's 1 sodium to 1 chlorine, is because you have 1 positive charge and 1 negative charge, and those balance each other out. Right? If I had another Cl minus, now I'm no longer balanced because now I have 2 negatives and only 1 positive. So again, I cannot just change the formulas. You have to leave the formulas alone, right? Gotta leave it alone. You can't just add or subtract atoms from a formula because it's convenient for you. What we do is we just change the coefficients. We say that, oh, maybe I want 2 sodiums or 2 chlorines or something like that. So, and I'm going to mention some of these tips on the next page here, but one of the things that I'm going to ask that you do is that you should always start by having an inventory. And by an inventory, I mean just make a note of what you start with and what you end with, right? So in this one, I have, as far as sodiums go, I have 1 sodium. As far as chlorine atoms go, I have 2. If I look on the right-hand side, I have 1 sodium atom, and on the chlorine, as far as chlorines go, I have 1 chlorine, right? So my problem is not with sodiums, I have 1 of each. My problem is with chlorines, namely that I have 2 here and only 1 here. So how am I going to fix that problem? Obviously, I need 2 chlorines on the right-hand side. So what I'm going to do is I'm going to say that if I need 2 chlorines, what that means is I need to have 2 sodium chlorides. And notice that I didn't put a 2, I didn't put a subscript behind the chlorine because again, I can't change the formula. I put a 2 as a coefficient in front of that sodium chloride. So now that means I have 2 sodium chlorides, which means I have 2 of those things. So I fixed that problem. I now have 2 chlorines, but I also have 2 sodiums now, right? Because if I have 2 sodium chlorides, that means I have 2 sodium atoms and 2 chlorine atoms. So I fixed my chlorine problem, nailed it, right? 2, I started off with 2, I ended up with 2, perfect. But now I screwed up my sodiums when I added that coefficient, right? Or over here I have 2 on my product side, but I only have 1 on my reactant side. Well, I can fix that by adding a 2 in front of the sodium, right? If I say I have a 2 in front of the sodium, now that's saying I have 2 sodium ions, or 2 sodium atoms, excuse me, and now I can change my total number of sodiums to 2. And now I have 2 sodiums on the left, 2 sodiums on the right, and I have 2 chlorines on the left and 2 chlorines on the right. So this would be my balanced equation. I have balanced my equation. And again, notice, right, all I did was I just added coefficients. So now the balanced equation here, and I'll write this down so that it's all together, is that I have, if I take 2 sodium atoms and 1 chlorine molecule, I will make 2 sodium chlorides. And this is my nice balanced equation. That's what the real coefficients are. That's what the real ratios are, the mole ratios between things. And these coefficients will become more important in the future if you are doing math with these equations. If you're looking at percent yields or limiting reagents or something like that, that'll be really important. So let's look at some more examples. So, or actually, sorry, the strategies here, right? So I mentioned that there are some strategies. I already showed you the first one here, which is just make an inventory, and I'll do that for the other ones, right? Number one thing, make an inventory. Also, I find that it's really useful to start with whatever element, whether it's sodium or oxygen or whatever, start with the element that's in the fewest of the chemical species. And again, I'll show you what that means in another slide. Oftentimes, this means you'll save the pure elements for last, just because they're easy to fix. Because when you change the amount of a pure element, you don't change any other element, so you don't have to go in circles, right? And you'll as soon as you start doing these, you'll probably feel yourself going in circles. But we're trying to avoid that and solve these as quick as possible. And the last one is just that if you see the same polyatomic ion on the left and the right-hand side, on the reactant and the product side, just keep it together. Don't break it up. So if you see like sulfate on the left and sulfate on the right, don't list it as 1 sulfur and 4 oxygens. List it as 1 sulfate. Just keep the whole sucker together. It'll be easier to manage, and it'll just help you get to the balanced equation a little more quickly. So I want to go through each of these in a little bit more detail. So the inventory, right? I kind of already mentioned the inventory thing to you, but I'm going to show you 2 more examples here. So again, it looks like I have 1 aluminum on the left-hand side. Looks like I have 2 oxygens on the right-hand side, right? Because I've got a subscript 2 here. On the product side, it looks like I have 2 aluminums because I got that subscript, and that I've got 3 oxygens. So both of these are messed up. So I just need to start somewhere and start adding a coefficient in front of something. I need to start changing something. So I am going to go ahead and deal with my oxygens, right? I have 2 oxygens on the left, 3 oxygens on the right. That seems kind of hard, right? Because I can't have like a half of an O2 molecule, right? It comes in 2s. And I can't just like add 1 oxygen to the right-hand side of my aluminum oxide because aluminum oxide is that formula. I can't change that. So I need to find their lowest common multiple here, which would be 6. So what I'm going to do is I'm going to put a 2 in front of the aluminum oxide, which is now going to give me 6 oxygens, right? Because if I have 2 aluminum oxides, I have 3, and then I have 3 again. And that gives me 4 aluminums, because again, if I have 2 aluminums and 2 aluminums again, that's going to give me 4, right? So when I say 2 Al2s, that's saying that I have this and I have that. So 6 oxygens altogether, 4 aluminums altogether. If I want to get 6 oxygens on the left-hand side, I just need to put a 3 in front of this O2 to give me a 6. So I've fixed my oxygen problem. I have 6 on the left, 6 on the right. Great. But if you're looking at this, right, now I've got an aluminum problem, right? I'm starting with 1 aluminum, but I end with 4 aluminums. That should be relatively easy for me to fix because it looks like I need to add aluminums on my reactant side, on the left-hand side here. And since aluminum's just by itself, all I really need to do is just slap a 4 in front of there to change my number of aluminums to 4. Now I have 4 aluminums on the left, 4 on the right. That's all nice and balanced. That would be my balanced equation. 4 aluminums, 3 oxygens makes 2 aluminum oxides. And again, please note, right, that I am not doing things like putting a subscript here, right? Subscripts are for within a formula, like we have for this 2 here. We're only changing coefficients, right? We only change coefficients. That's it. Let me do the example down here. Again, I'll create my inventory. I've got HCl, so it looks like I've got 1 hydrogen. Looks like I've got 1 chlorine, and I've got 1 zinc. If I go to the right-hand side, it looks like my number of hydrogens now is 2, my number of chlorines is 2, and my number of zincs is 1. So I only have 1 zinc atom on either side, so that seems fine. Seems like we're good to go. But on the right-hand side, I have extra hydrogens and chlorines, right? I have 2 hydrogens and 2 chlorines on the right-hand side, but I only start off with 1. And luckily for me, that just means that I need to add hydrogen and chlorine, and they're already stuck together. So if I put 2 in front of this HCl, that changes that to 2, that changes that to 2. So now I have 2 hydrogens on either side, 2 chlorines on either side, 2 zincs on either side. That's the only coefficient I needed to add here. So then I'm set. That one's nice and balanced, right? So when you have that inventory, it really gives you a good place to start, and it helps you keep track of things. So what about starting with the element that is in the fewest of the chemical species? What on earth do I mean by that? So let me first take my inventory. Number of carbons that I have, looks like I have 4 on the left. Number of hydrogens, looks like I have 8. Number of oxygens, looks like I have 2. On the right-hand side, looks like I only have 1 carbon. Looks like I have 2 hydrogens. And it looks like I have 3 oxygens. So everything's all messed up. So the question is, where do I start? Where am I going to start? Do I start balancing oxygens or hydrogens or what? So what I'm saying here is, start with what element. I've got carbon. So if I look at carbon, it looks like carbon is in 1, 2 of the 4 things in this equation on both sides, right? I see carbon in the first thing on the left, and I see carbon in the first thing on the right. The butane, or it doesn't matter, butene, and the carbon dioxide. So I'd say carbon is in 2 of 4 of these chemical species. If I go to hydrogen, I see hydrogen is in that, and I see hydrogen is in water. Hydrogen also is in 2 of 4 of the things in the equation. And then lastly, I see oxygen is by itself on the left-hand side. I see oxygen is in the carbon dioxide, and I see oxygen is in the water. So oxygen is in 3 of the 4 chemical species in this equation. So what I'm saying with this strategy, with this tip, is that I would save oxygen for last, and I would do one of these first. Because oxygen is in so many things, when you start changing the number of oxygens in your equation, it's going to affect more species, and it's just going to be a bigger headache. It's not that you can't start with oxygen. You can. That's fine. It may be a little more roundabout. You may have to go and change something and then change it again later when you mess it up, and then it just might take you a little longer. That's all. It's not that you can't do it. It's just I recommend you save it for last because it's going to be trickier. So I can start with carbon or hydrogen here. They're both only in 2 of the 4 things, not in 3 of the 4 things or 4 of the 4 things. So I'm going to start with carbon just because I have it written first here. 4 carbons on the left, 1 carbon on the right. So I'm going to put a 4 in front of my carbon dioxide so that this carbon changes to 4. But by putting 4 in front of the carbon dioxide, it's true that I have 4 carbons, but I also have more oxygens now, right? So if I have 4 carbon dioxides, that means I have 8 oxygens now. And I'll just write extra carbon dioxides here just so we can visually see it. So what we're saying now is that in addition to the black CO2, I now have 3 green CO2, so I have 4 altogether. And that means I have 2, 4, 6, 8 oxygens from carbon dioxide plus the 1 from the water. So I now have 9 oxygens, right? 8 from the carbon dioxides plus the 1 from water. So by adding that 4, I changed my carbons and my oxygens. But I fixed my carbons. My carbons look good. Now I'm going to go to my hydrogens, try to fix those. I have 8 to start with, but only 2 to end with. So in order to get that to balance out, I need to put a 4 in front of my water so that I have 4 waters now altogether. So same thing, I have another water, and another water. So I have 4 waters altogether, which gives me 8 hydrogens. And it also changes my number of oxygens, right? Because water has oxygen in it. So I now have 1, 2, 3, 4 oxygens from water. And I have 8 from my carbon dioxide. So 4 plus 8 is 12. So I have 12 oxygens altogether. 2, 4, 6, 8, 10, 12. But I fixed my hydrogens, so we're all good. So I fixed my carbons, fixed my hydrogens. Nailed it. Now I'm going to come to my oxygens, right? I'm going to save that for last. And this is also, it's kind of nice when you save pure elements for last, because when you add a coefficient to them, they only affect that element. They're not going to affect like carbon and hydrogen and oxygen or something like that. So I need 12 oxygens altogether on the left-hand side. These come in 2s. If I need to get up to 12, I just need to put a coefficient of a 6 in front because 2 times 6 is 12. And then I've got a balanced equation. So it looks like my balanced equation here would be C4H8 plus 6 O2s goes to 4 CO2s and 4 waters. Exactly like that. So that would be my balanced equation. And again, you could have done this, you could have started with different elements, but I'm just saying that it tends to be easier if you start with the elements that are in the fewest number of the species in the equation and you save the ones that are in the most for last. It tends to just be simpler. Let's look at so we've got, the last one is that if you see the same polyatomic ion on both sides of the equation, just keep that ion together, do not break it up. So like here, for example, right, I could do this like I could take my inventory like I have the other ones, where on the left-hand side, I might say how many potassiums, how many nitrogens, how many oxygens, and how many hydrogens I have. But that's going to get kind of messy fast because if you notice, I have oxygen in every species. Oxygen is in 4 of these species, which means it's going to be really annoying and frustrating to start balancing oxygen because every time you change one coefficient in front of one species, one chemical species, you're going to change other elements also, which starts to become a headache and you feel like you go round and round and round. So what I would do is, since I see nitrate on the left and nitrate on the right, and I see carbonate on the left and carbonate on the right, I'm just going to keep those together as ions. I'm not going to break them up. So like I'm going to say, for example, that I see 1 potassium, and I'm going to say that I see 1 nitrate. And I'm going to say that I see 2 hydrogens for the carbonate, and I'm going to say that I see 1 carbonate. And then I'm going to look to the right and do the same thing. So potassiums, I see 2. Carbonate, I see 1. Hydrogens, I only see 1. And nitrates, I only see 1. So that's what I mean by keeping that ion together, right? I didn't break it up. I left the carbonates, sorry, that should be CO3 over here. The carbonates are still together, the nitrates are still together. And then it's going to make my balancing so much more simple and straightforward because I'm dealing with chunks of compounds that stay the same. So if I look at my potassium problem, I start with 1 potassium and end with 2 potassiums. That's not balanced. So I have to add a 2 in front of here. So I have 2 potassium nitrates. That's going to change this potassium number to 2 and my nitrate number to 2. Right? So that made it kind of simple. If I have 2 potassium nitrates, I now just double the amount of those. I don't have to be like, oh, I doubled the amount of nitrogens that I have, and now I have 6 oxygens. That would just, again, be kind of a headache. So I fixed my potassium problem, but I created a nitrate problem, right? Now I'm saying that I start with 2 nitrates, but I only have 1 to end with. So I got to fix that. Over here on the right-hand side, on the product side, I can put a 2 in front of the hydrogen nitrate, the nitric acid. So now my number of nitrates goes up to 2, as does my number of hydrogens, right? Because if I have 2 hydrogen nitrates, And that means I have 2 hydrogens now and 2 nitrates. So my nitrate problem is fixed. Looks like my hydrogens are 2 on either side and my carbonates are 1 on either side. So I'm set. That's my balanced equation, right? So this would be my balanced equation. And again, you don't have to use these strategies. There are other ways to solve these, but these are just some tips that I think really help folks out at the very beginning. So hopefully you feel a little bit more comfortable in approaching these balancing equation type problems. Definitely do a lot of practice. When you get good at it, it's kind of fun. Students tend to kind of like it. They're like, oh, good, these are easy points. I know how to balance an equation. But just spend the time practicing so that you know that you can do it and you're confident in your skills. Happy studying. Please let me know if you have any comments or questions down below. Best.